Genomics, that is studying the gene to find out various diseases. But apart from genomics, there are also many other omics which have come. So we have proteomics, transcriptomics, metabolomics, lipidomics, many other omics have come. Of course, it's very difficult for one lab to do all the omics, but since we have already been doing a lot of work in genomics, we are now expanding that. And one of the new equipments, which thanks to the collaboration with Premas, we have been able to establish here, is what is called as a next gen sequencing, a very advanced genomic facility. And Dr. Ada and Mr. Praveen Gupta will talk about that. So what we are doing is, instead of just buying the machine and keeping it here, we are actually partnering with the Premas so that MDRF and Premas can take this forward and establish a new chapter in genomic testing, as well as not just genomic, but also proteomics and other facilities. So that's why we call it as multiomics. Of course, our focus will be mainly on diabetes, but when you study various genomics, you can also go into various other related fields like cardiovascular disease and so on. There's a lot of overlap between diabetes and cardiometabolic disease. So that's what this is all about. The partnership model is to develop collaborative expertise across research, technology, and gene sequencing. MDRF brings all the experience that we have with patients. We, as you know, we are perhaps the largest network of diabetes centers in the world today. More than 7 lakh patients have been registered at the center. We started the center 35 years ago, and ever since that, we have been having the records of all the patients. We also have very large epidemiological data. Apart from the patients who registered here, we have various epidemiological studies for which blood has been stored in our deep freezer and in our biobank at the Madras Diabetes Research Foundation in Siruseri as well as here. So with all this, there's a great opportunity to do some real world-class cutting-edge research. And that's where Premas Life Sciences come in, because they have got the technology, various assays which are developed. And the field is constantly changing, but they have been one of the leaders in bringing world-class technology to India. And so today we'll be signing an MOU and we'll be extending this partnership model. Of course, I won't spend time on why we are doing this. You all know that India is often referred to as the diabetes capital of the world. And whether we're the capital or not the capital is can debate that, because China also has lots of people with diabetes. But we certainly have very large number of people with diabetes, more than 100 million now, 136 million people with pre-diabetes. And also we have a lot of obesity, heart disease, and so on. We also have data which is India specific. So most of the data on diabetes from India comes from this institution. Probably this one institute itself produces maybe 25-30% of the entire research done in diabetes in the whole country. So we have lots of studies done, cross-section studies, longitudinal studies, and so on. And that's what we will be bringing to the table. Of course, MDRF's vision is that we are India-centric. When you say India, you can also apply to South Asia. So Pakistan, Bangladesh, Nepal, we share very similar genes and very similar habits, and therefore it can be extended to South Asians. And when you extend South Asians, you can also extend South Asians living in Singapore, Malaysia, and also in the US, Canada, and in other countries. So we are very good at data integration. So since we have these huge databases, we've been also integrating this. Our focus, as I said, will be on cardio-metabolic. And then all this, of course, is not just done to publish some papers and say that we did some research, but it has translational value. Why do people get diabetes despite not having obesity? Some people come to very thin, but they have severe diabetes. Why is that? Obviously, some genetic factor is working. And can we improve the treatment for these people? Can the people who are obese, people who are not obese, be treated in different ways? Also, you've heard about our work on monogenic diabetes. Dr. Radha and her team have been pioneering. By finding out a single gene defect, we can take children off insulin and treat them with tablets. All that we have been doing. So these are some of the things which MDRF, why did Premas come to us? Because we are very good with cohorts. So cohorts is you take a group of people and then follow them for 10, 15, 20 years. Then you'll see the development of the disease. So we have such data also. We have, as I said, biosamples. We have thousands, almost 1 billion samples now we have stored in our biobanks. Probably the largest and probably the only standalone diabetes biobank in the whole world to my knowledge. Multiomics from genomics, we are now through this collaboration, we'll be going to other omics like proteomics. And this also helps us to understand biology better, why we develop insulin resistance, why we develop insulin secretory defect, and so on. So the 4 areas where we'll be working on is, of course, diabetes and related diseases. Everybody today is talking about obesity. You have heard about the new drugs which have come for obesity. So everybody is talking about that. So that's an area which needs a lot of research. Cardiovascular, population-based genomics also we can do. We know about the ICMR INDAB study which Dr. Anjana was pioneering, and many times we presented here to the press about the INDAB study. So we have nationwide data. So we have South India, North India, West India, East India, Northeast, middle of the country, all that we have. Different genes work differently in different populations. And as I said, translational medicine is of very high value. What we are doing now is that we have acquired, and we'll show you the equipment, we have acquired very high throughput facilities where we can do the genomic testing much more easily. We also built systems for secure data management, bioinformatics. Once you get all this genomic data, it's not easy to analyze it. So for that, you need bioinformatics. That will also be part of this collaboration. And of course, we're very well known for our quality control. In fact, we'll be surprised and even happy to hear that while we think that we have to go to other countries to do studies, now the reverse is also happening. Very recently, we got samples from UK. So they sent all their blood samples to us saying that you do it in India. We are happy to send you. So all their entire samples came here. Similarly, we have had in the past where genomic facilities were there in the UK and so on, it was there. But still from the London School of Tropical Medicine and from other places, Germany and other places, they have sent us samples and said, you do it at MDRF. And they even sent their team to check the quality. And we found that the quality was very, very good. In fact, I'd like to share a story with you. There are 2 occasions through our collaboration, one with Norway and one with UK. We had Exeter, where the place, where supposed to be the mecca of genomic medicine. So we did one of our thing, once with Norway and once with this Exeter lab. We got a difference. And they reached out to us and said, why you have got this? So we rechecked it and they got different results and we got different results. So then we checked it and we said, I think we are right. Why don't you check yours now? And they checked it, and on both occasions we were right and they were wrong. So, our Prime Minister always talks about Make in India and so on. Here is an example where even the most advanced countries, the most advanced genomics labs, at least on 1 or 2 occasions, we have shown that we can actually be better than them. So I think today we are in an era where we have to think everything, not just be a follower, but be a leader. And I think that's what is the stage which India is in now. And in keeping with that, we thought that it is time that we extended our research facilities by bringing in very high-end equipment. And to talk about that equipment, over to Dr.
So how are we going to do, what is the new infrastructure that we are going to build, and how are we going to take our research from this level to the next level, to a very high level? So that is really powered by NovoSeq X. NovoSeq X is the machine that we have procured from Premas, and we have installed it in Siruseri, MDRF, which is about 30 kilometers from here. So what does it do? So it does, so far we've been doing gene by gene, very slowly, one by one. And doing one by one, the speed is going to be really low and low throughput. So now, because of this machine, we are really able to scale up, and then we are able to really do an unprecedented speed with which we are able to do the work. And what does that give? That gives us enormous power. That gives us, now we are able to easily deliver precision medicine, easily deliver to the clinic, the very fast, very good quality product, very good quality measurements, genetic measurements, etc. And then we are able to expand the capacity to various, the population we are able to expand. For example, what we were doing in, hundreds and thousands, we used to take about 1 or 2 years to do. And within no time, within a month, we are able to finish about 5,000 samples. So that is enormous. So within a year, we would have finished some more than a lakh, 100,000 samples of genome sequencing, etc. Because it has got that kind of power in speed as well as in taking the throughput higher. It doesn't stop there. There is one more dimension to this: the research grade accuracy. So this technology is extremely accurate and very, very precise. So Tamil sollanuna romba thulyam. So tulyama pandra research can be, that is the precision medicine, can certainly be delivered by this machine. That is the reason why we got this technology to MDRF. I'll just walk you through the lab of MDRF, because you're not able to be there, and we are obviously can't bring the lab or the instrument here. So let's go into the molecular genetics facility, and particularly the new facility that we have opened. And these are all a part of this technology. That is Dr. Mohammed Imran, who's just sitting there. So he is the main person, Dr. Imran. So he's the main person who's working on this along with us. And this is the machine that we are talking about, the NovoSeq X. So this is a high throughput next generation machine. Even the closing and the opening and putting in the sample, everything, it's a highly automated system. So we will just show you a little bit of that. So this is where the samples are kept, and once that closes, and then once the program is done, everything is, all the readings and measurements come over. So what exactly would be the impact of this? What is the point in just taking it from one level to another level? The main thing is the impact. And what sort of impact? It has to be a clinical impact. That is where it's going to help everybody, all the people here. One is the early detection of diabetes itself, because of the speed, because of the thoroughness that it does. And second is, you're able to stratify people very well, very accurately. That is also possible by this, because every little thing is right here, and then it helps in biomarker discovery. This is a very good discovery, either genetic discovery, proteomic discovery, biomarker discovery. So discover so many things that are not known now will come to the open for us. So that is something that we are really looking forward to. So the novel things will come up, and then with that, we are also able to understand the biology. That is, to develop how the precision pathways are there with respect to treatment. As I said, it's very important that the impact has to be clinically oriented. So how can the treatment be based on genetics, which has happened? And as we open up, novel understanding and insights, we will certainly be able to deliver novel treatments also. That is going to be the very big impact of this machine. Can I invite Dr. Mohan to the stage too?
So what we are going to build in short is shown here. We are going to build a future-ready genomics and multiomics. So right now we'll be doing genomics and proteomics, but eventually we'll probably build other platforms as well. So Dr. Adam mentioned about the NovaSeq X Plus. It's a very advanced system which helps to sequence thousands of genomes, and over the next few years we'll be expecting, you can expect to see breakthrough research coming from here. And we have a 5-year genomics vision, so we already planned for the next 5 years what is to be done. This will be our roadmap. 30,000 genome sequencing we will be doing. At least 30 different research projects, new research projects we'll be taking on, and 100% data integration will also be done with complete multi-omics data generation. I don't think such a facility in any diabetic center is there. I now request Mr. Praveen Gupta to come and talk to us why we chose Premas.
Thank you, Radha. Thank you, Dr. Anjana. It's a real pleasure to be here right now. It's been a long cherished dream for us to actually have a very advanced facility at MDRF. And I'm so personally glad and happy that today the day has come that we have a world's most advanced sequencer, which is basically a multi-omics tool installed at MDRF. I just want to give you a little brief glimpse why Premas and what is Premas. Premas is a 20-year-old organization which has been operating in India. We are known to be bringing some of the most cutting-edge technologies in the country. We have partnered with brands like Illumina, which are market leaders in multi-omics technologies. We have close to about 25 PhDs who are working with us, and we have been instrumental in basically partnering with lots of cutting-edge projects in the country. The large-scale 10,000 genome project or a COVID-seq project, or any other large-scale project, we've been basically part of it. So today, when we got a chance to basically work with the leaders in the metabolic disorder space, MDRF said 7 lakh patient data, a large cohort projects here, such a large biobank, massive clinical history. Imagine a setup like this is powered with the most advanced technology for doing multiomics. How this can power that India, which is currently importing most of its diagnostic tools from outside, can we develop using the technology here on the Indian biodiversity samples? Can we discover novel biomarkers here? Can we develop panels here? Can we actually tomorrow serve the global south from India in partnership with the critical leaders like India? That's the dream and that's the passion which we want to basically work upon. And that's why Premas came in. So with this collaboration, not only we are looking at doing joint projects here, developing products here, we are also trying to see that how do we, this is a very rare place where in a clinical setup, we have such an advanced machine right now. In the entire country, there won't be any example of a very large clinical setup having such an advanced machine which can do so many multi-omics samples. Now imagine this power of having knowing the clinical history, phenotype, and along that, if you add a multi-omic angle, the power which you bring in the technology and the science. So not only it ups the research findings, but the kind of interventions you can plan for the precision medicine future. It is humongous. So we can lead here. We can genuinely exist truly made in India, discovered in India, and made in India opportunity for us in the space of cardiometabolic disorders. And in that, I've spoken to Dr. Mohan. We are very open that not only our own projects, there are a lot of academic projects where they do not have the technology. And I can tell you some of the biggest hospitals in the country, they have fundings to basically do projects, but they do not have this technology. And if we are tomorrow looking at Premas can tomorrow work together and we can get those projects here, which are done with ethics. And as you gave an example about Exitum, how the data quality, which is world class, can be combined together. The confidence of the data of some sort is very, very hard, very, very accurate out here. So we are looking at creating that part. We are trying to also create skill. India can become a capital where we can provide skilled manpower to the world. We have a massive employment issue. globally also in India too. These are technologies which will rule the diagnostic space in the next 15, 20, 30 years. Can this collaboration tomorrow create a constant, steady pool of trained manpower here, which can go to the global markets for employability? And that's a good opportunity which we have here. How do we also create industry academia collaboration? India outside of US has the largest pharma base, but India currently is being mostly serving the generic space. But now times have changed. Indian companies are also looking at creating new drug discovery. Now, a tool, a platform like this with the clinical strength which MDRF has, imagine tomorrow we are partnering with Indian pharma companies to do drug discovery, novel biomarker discoveries on which discoveries can happen, and we can join hands together and we can work out. Similarly, Government of India is planning some very, very large scale projects. Till now, the biggest project in the Government of India is 10,000 genomes. We've been hearing that DBT is planning to do a very, very large scale project because UK is talking about million genomes, US is talking about million genomes, Middle East is talking about million genomes. India is also talking the same breadth now. So if such a thing has to happen, this will be a combination of disease samples and also healthy samples. This institute, with the kind of power you have now, can be a collaborative partner to the Government of India to do those large scale studies in here. Those samples does not have to leave the country. Instead, we can have global samples coming to India now with this kind of a partnership. That's great. So we are genuinely excited about creating not only national collaborations, but also international collaborations and developing products here, which will be serving the global south, not just the country. So we are really, really excited about this partnership. I'm personally honored that Dr. Mohan, Dr. Radha, Dr. Anjana have agreed to partner with us, and we look forward to having a very, very long and cherishful partnerships here. Thank you.
அதாவது MDRF சொல்றது Premas Life Sciences கூட சேர்ந்து ஒரு MOU சைன் பண்ணிட்டு நாங்கள் கொலாபரேஷன் வந்து ஸ்டார்ட் பண்ணியிருக்கிறோம். இது என்ன இதில் புதுசாக நாங்கள் பண்ண போகிறோன்னு கேட்டிங்கன்னா, ஜெனட்டிக்ஸ் ஜெனோமிக்ஸ்ன்றது உங்களுக்கு எல்லாருக்கும் தெரியும். நம்ம ஜீன்ஸ் அணுக்கள் பாடியில் இருக்கிறதா நமக்கு வந்து ஒவ்வொரு வியாதிக்கும் ஒரு பேசிஸ்ன்னு சொல்லலாம். இதை வந்து ஸ்டடி பண்ணுறது வந்து அவ்வளோ சுலபம் இல்லை. ஏன்னா இப்போ ரொம்ப சொஃபிஸ்டிகேட்டட் எக்யூப்மெண்ட்ஸ் எல்லாம் தேவைப்படுது. இதில் லேட்டஸ்ட் எக்யூப்மெண்ட் தான் வந்து இந்த ஹோல் ஜினோம் சீக்வன்சிங் சொல்ல. அதாவது நம்ம பாடியில் இருக்கிற உடம்புல இருக்கிற ஒவ்வொரு அணுக்களும் ஒவ்வொரு ஜீனும் ஸ்டடி பண்ணிட்டு ஒரு ஹோல் சீக்வன்ஸை ஃபுல்லாக ஸ்டடி பண்ணுறதுன்னா முன்னெல்லாம் திங்க் பண்ணவே முடியாது மாதிரி பண்ணுறதுக்கு. ஆனால் இப்போ வந்து இருக்கிற மாடர்ன் எக்யூப்மெண்ட்ஸில் இப்போ நோவா சீக் எக்ஸ்பிளஸ்ன்னு சொல்லிட்டு ஒரு புது எக்யூப்மெண்ட் வந்திருக்கு லேட்டஸ்ட்டு. அதை வந்து இந்த பிரேமாஸ் லைஃப் சயின்சஸ் என்ன சொன்னாங்கன்னா, உங்ககிட்ட இத்தனை சாம்பிள்ஸ் இருக்குது, பிளட் சாம்பிள்ஸு இது டேட்டாலாம் இருக்குது, நாங்கள் வந்து எங்களுடைய எக்யூப்மெண்ட்டு வச்சுட்டு ஒரு ரிசர்ச் கொலாபரேஷன் மாதிரி ஸ்டார்ட் பண்ணலாம். நீரிழிவு நோய் எதனால் வருது, எத்தனை வகையான நீரிழிவு நோய் இருக்குது, அது ஏன் சிலவங்களுக்கு மாத்திரம் காம்ப்ளிகேஷன்ஸ் வருது, என்ன ட்ரீட்மெண்ட் கொடுத்தா இது வந்து கண்ட்ரோல் பண்ணலாம், குழந்தைங்களுக்கு ஏன் வருது, சில குழந்தைங்களுக்கு வந்து நீரிழிவு நோய் இருக்கும், அவங்களுக்கு இன்சுலின் தேவைப்படாது, ஆனால் சில குழந்தைங்களுக்கு இன்சுலின் தேவைப்படும். இதெல்லாம் வந்து ஜெனட்டிக் டெஸ்ட் பண்ணிட்டா கண்டுபிடிக்க முடியும். எங்களால் வந்து இந்த சின்ன கை குழந்தைக்கு கூட இன்சுலின் இல்லாமல் மாத்திரைது கூட நாங்கள் பண்ணியிருக்கிறோம். ஆனால் அதுக்கெல்லாம் வந்து ஜெனட்டிக் டெஸ்ட் பண்ணிட்டு தான் அது வந்து பண்ணணும். அதே மாதிரி நீரிழிவு நோயிலேயே டைப் 1 டயபெட்டிஸ் இருக்குது, டைப் 2 டயபெட்டிஸ் இருக்குது, டைப் 5ன்னு போடணும் கண்டுபிடிச்சிருக்காங்க. மெச்சூரிட்டி ஆன்செட் டயபெட்டிஸ் ஆஃப் யங் மோடின்னு சொல்ல, MODY, அது ஒரு டைப் ஆஃப் டயபெட்டிஸ். இந்த மாதிரி எல்லாம் கண்டுபிடிக்கணும்னா சும்மா பிளட் டெஸ்ட்னால எல்லாம் கண்டுபிடிக்க முடியாது, ஜெனோமிக் டெஸ்டிங் பண்ணணும். இப்போ ஜெனோமிக்ஸ்ன்றது ஒரு ஃபெசிலிட்டி. அது கூட வந்து புரோட்டியோமிக்ஸ்னு ஒன்று இருக்குது. அதாவது இந்த ஜீன் எப்படி வேலை செய்யுதுன்னு கண்டிப்பா புரோட்டீனை ஸ்டடி பண்ண, அதுதான் புரோட்டியோமிக்ஸ்ன்னு சொல்லுவோம். அது ஒன்று வந்திருக்கு. எபிஜெனட்டிக்ஸ்னு ஒன்று இருக்குது. அதாவது ஜீன் இருக்குது, ஆனால் அந்த ஜீனை வந்து ஆன் பண்ணுறதும் ஆஃப் பண்ணுறதும் வந்து அந்த என்விரான்மெண்ட் சுற்றுப்புற சூழ்நிலை காரணங்கள், அதுதான் எபிஜெனட்டிக்ஸ்னு சொல்கிறது. அது இதுவரைலாம் நாங்கள் பண்ணதில்லை, அதுவும் இப்போ ஆரம்பிக்க போகிறோம். ஸோ இந்த மல்டி ஓமிக்ஸ்ன்னு சொல்லுவோம், ஜெனோமிக்ஸ், புரோட்டியோமிக்ஸ், டிரான்ஸ்கிரிப்டோமிக்ஸ், இதெல்லாம் வந்து சேர்ந்து முதல் தடவையாக ஒரு நீரிழிவு நோய் மருத்துவமனையில், ஒரு நீரிழிவு நோய் ஆராய்ச்சி மையத்தில் இந்தியாவில் எனக்கு தெரிஞ்ச உலகத்திலேயே ஒரு டயபெட்டிக் சென்டர்ல ஃபர்ஸ்ட் டைம் ஸ்டார்ட் பண்ணியிருக்க போறோம். இதுல வந்து அட்லீஸ்ட் ஒரு 30 புது ரிசர்ச் ப்ராஜெக்ட் ஸ்டார்ட் பண்றோம்னு இருக்குது. அண்ட் இன்டர்நேஷனல் கொலாபரேஷன் கூட வந்துட்டு இருக்கு. நேஷனலி ஆல்சோ எல்லா பெரிய இன்ஸ்டிடியூட்ஸ் கூட நாங்கள் ஒர்க் பண்றோம். ஆல் இந்தியா இன்ஸ்டியூட் ஆஃப் மெடிக்கல் சயின்சஸ், சிடிசி டெல்லி, அப்புறம் நிம்ஹான்ஸ் பெங்களூர், இவங்க கூட எல்லாம் நாங்கள் கொலாபரேட் பண்ணிட்டு நேஷனல் இன்ஸ்டியூட் ஆஃப் நியூட்ரிஷன் ஹைதராபாத், இந்த மாதிரி பெரிய பெரிய இன்ஸ்டியூட்ஸ் கூட எல்லாம் ஒர்க் பண்ணிட்டு மக்களுக்கு ரொம்ப சுலபமாக நீரிழிவு நோயை டயக்னோஸ் பண்ணிட்டு சிகிச்சை முறைகளை இம்ப்ரூவ் பண்ணிட்டு நீரிழிவு நோய் இன்னும் நல்ல கண்ட்ரோல்ல வச்சுட்டு நீரிழிவு நோய் வர்றதுக்கு முன்னாடியே கண்டுபிடித்து அதை ப்ரிவென்ட் பண்றதுக்கும் இதெல்லாம் வந்து எங்களுக்கு ஐடியாஸ் வந்து இந்த கொலாபரேஷன்னால நாங்க எஸ்டாப்ளிஷ் பண்ணோம். வந்து ஒரு பீஸ் மீலா செய்துட்டு இருக்கோம். அதாவது ஒரு ஜீன் நம்ம ஏதாவது சஸ்பெக்ட் பண்ணா இந்த வியாதி இருக்குமா, அதுக்கு ஒரு ஜீன் இருக்கும். அந்த ஜீனை மாத்திரம் நாங்க ஸ்டடி பண்ணிட்டு அப்ப இன்னொன்னு நம்ம மிஸ் பண்ணிடுவோம். இப்ப நாங்க பண்ண போறது அந்த மாதிரி இல்லை. ஹோல் ஜீனோம், ஹோல் பாடியை வந்து ஃபுல் ஜெனட்டிக் ஸ்கிரீனிங் வந்து ஒரே டைம்ல வந்து கண்டுபிடிக்க முடியும். அப்போ வந்து அதனுடைய அட்வான்டேஜ் என்னன்னு கேட்டீங்கன்னா, சம்டைம்ஸ் நம்ம திங்க் பண்ணாதது வந்து அதுல கண்டுபிடிச்சிடுவோம். இன்ஃபேக்ட் இந்த டைப் 2 டயபெட்டிஸ் ஜீன்ஸை பற்றி பேசும்போது ஸ்ட்ராங்கஸ்ட் ஜீன், இந்த டைப் 2 டயபெட்டிஸ் ஸ்ட்ராங்கஸ்ட் ஜீன் வந்து TCF7L2ன்னு சொல்றது ஒரு ஜீன். அந்த ஜீன் முதல்ல கண்டுபிடிக்கும் போது அதை பற்றி யாருமே திங்க் பண்ணதே இல்லை. திடீர்னு அந்த இன்ஸ்ட்ருமெண்ட்ல அதை காட்டிடுச்சு. என்ன அது புதுசா வந்திருக்குன்னு பார்த்தா அந்த மாதிரி ஒரு ஜீன் இருக்குது. ஸோ நம்ம வந்து ஃபிக்ஸட் ஐடியாஸ்ல போனா இப்படிதான் இருக்கும் அப்படிதான் இருக்கும்னா சம்டைம் வி மே பி ராங், கம்ப்ளீட்டா தப்பா இருக்கலாம். அதனாலதான் இப்ப AI இஸ் ஏபிள் டு டூ பெட்டர் தென் அஸ். பிகாஸ் நம்ம வந்து நம்ம எக்ஸ்பீரியன்ஸ் வச்சு இப்படிதான் இருக்கும் அப்படிதான் இருக்கும். அஃப்கோர்ஸ் 80% கரெக்டா இருக்கும், 90% கரெக்டா இருக்கும், 10% we could be wrong. இது ஒரு பயசும் இல்லாம கம்ப்ளீட்டா ஹோல் ஜீனோம் ஸ்டடி பண்ணும்போது புது புது ஜீன்ஸ்லாம் கண்டுபிடிக்கிறோம், which we never thought of at all. அதுதான் அட்வான்டேஜ். தட் இஸ் சம்திங் நியூ. முதல்ல நாங்க பண்ணப்போ இதுவரைலாம் அது பண்ணதில்லை. This is not a test done commercially. ஸோ இது வந்து ஒரு பேஷண்ட் வரும்போது நீங்க இந்த டெஸ்ட் பண்ணிட்டு அப்புறம் உங்களுக்கு ட்ரீட்மெண்ட் கொடுக்குறோம் அந்த மாதிரி நாங்க பண்றது இல்லை. ஆக்சுவலா நாங்க ரிசர்ச்சுக்காக பண்ணும்போது பேஷண்ட்டுக்கு ஒரு சார்ஜும் கிடையாது, கம்ப்ளீட்லி ஃப்ரீ ஆஃப் காஸ்டா தான் நாங்க பண்ணுவோம். அஃப்கோர்ஸ் சப்போஸ் இன்னொரு இன்ஸ்டிடியூஷன் இப்போ பாம்பேல இருந்து கேட்டாங்க, ஒரு கல்கட்டால இருந்து நீங்க எங்களுக்கு ஒரு 1000 பேருக்கு ஸ்டடி பண்ணி கொடுக்குறீங்கன்னா எங்களுக்கு காஸ்ட் இருக்கு. ஸோ வி வில் நாட் பி ஏபிள் டு டூ கம்ப்ளீட்லா ஃப்ரீ. ஒரு குழந்தைக்கு பண்ணோம்னா அது மாதிரி பண்ணலாம். பட் ஒரு ப்ராஜெக்ட், அவங்களுடைய ப்ராஜெக்ட் எங்களுக்கு அவுட் சோர்ஸ் பண்ணியிருக்காங்கன்னா வில் ஹேவ் டு சார்ஜ். பட் வில் பி காம்படிட்டிவ். மார்க்கெட் இருக்கிறதோட வில் ரொம்ப காம்படிட்டிவ். வி டோன்ட் வாண்ட் மேக் மணி அவுட் ஆஃப் திஸ். வி வாண்ட் டு சர்வீஸ் பீப்புள். ஸோ அந்த மாதிரி பிகாஸ் எக்யூப்மெண்ட் இஸ் அவைலபிள், நிறைய டைமும் இருக்கும் அதில் பண்ணுறதுக்கு. ஸோ மற்ற இன்ஸ்டிடியூஷன்ஸ் எங்களை அப்ரோச் பண்ணாங்கன்னா வில் டூ இட் அட் காஸ்ட் ப்ரைஸ் ஆர் சம் இதை வந்து அவங்களுக்கு பண்ணி கொடுத்துரும். பட் நாட் ஃபார் த பேஷண்ட். பேஷண்ட்டுக்காக வி வில் நாட் சார்ஜ். திஸ் இஸ் நாட் எ கமர்ஷியல் ப்ராஜெக்ட் அட் ஆல். பேஷண்ட்டுக்காக பேஷண்ட் வில் நாட் பே எனிதிங் ஃபார் திஸ். சரியா?